We're missing one. Oh, Hannes has got. He's handing over expensive equipment, which is always a dangerous thing to do. Although I'm sure Thomas is very trustworthy, aren't you, Thomas? So we have now. I'm going to leave the screen off because I've got nothing that I want to do, and I don't want to blind members as well. So. This is called Attestation and the key role it plays in confidential computing. And I think we all know how important attestation is, but this is an opportunity to get some views from experts who maybe come at it from a slightly different point of view or have particular thoughts they want to bring, and hopefully they're going to disagree with each other. We can have an interesting conversation. We'll see if we can get that. We have, starting from this end, Ian Oliver. Ian, do you want to introduce yourself?
Yeah. I'm Ian Oliver. I'm actually ex-Nokia Bell Labs, now University of Oulu, specialising in, well, I did all the remote attestation stuff at Nokia. Something like that.
Thank you. Paul Howard?
Yeah, hi everyone. I'm Paul Howard. I'm a solutions architect with ARM. I work in a systems prototyping team, and what we focus on really is looking at ways to help developer communities and software ecosystems make the most out of new features of the ARM architecture. And as for new features of the ARM architecture, I'm currently focused on our confidential computing architecture, which is why I'm here. So quite a lot of the work I'm doing at the moment is about figuring out how we bring confidential computing to developer communities and to ecosystems successfully.
Yay, thank you. Hannes, I'm going to go Tschofenig.
Yeah, Hannes.
Okay, Hannes. Okay, fine.
Yeah, it's a complicated name. Anyway, yeah, my name is Hannes Tschofenig. I contribute here to this panel expertise on standards making, specifically remote attestation. And I've been working with some of the folks in the audience here, and even next to me on those standards. And obviously, that's something quite important to me. Also, the architectural aspects.
Excellent. And Yuxuan Song.
Yes, yes. So hi, I'm Yuxuan. I'm currently a PhD student in Inria, Paris and Sorbonne University. So actually, I'm not as experienced as the others, but I'm still learning. And my topic is on like remote attestation for low power constrained environments.
Thank you. So the first kind of place I'd like to start is by acknowledging that attestation means a lot of different things to different people. I was in the OpenSSF set of talks earlier on today, and they use attestation. They're talking about something almost completely different. So I want to be clear that we want to focus today on attestation for confidential computing. Now, we may touch on other things as well, because I know that some of you have interest in things like that, but that's kind of the main focus I want to keep that to. But the first thing I'd like to talk about is trust, because, well, A, I wrote a book about it, and B, because it's one of those things that we need to think about when we're putting together attestation. And I think, well, first of all, does anyone want to sort of own who are the key, what are the key components to an, well, who are the key entities we talk about attestation? Does anyone want to do that? We can use the RATS definition if we want. Hannes, do you want to go with that?
Yeah, maybe I start. Yeah, you pointed to the RATS work, which I think is also helping to clean up some of the difficulty in talking to people about attestation, because in many of the discussions I'm having with, like in standards groups, or also within companies, I'm working with also with Siemens, is that there's so many definitions, often very loosely defined, so it's a hard time to even get across what you are meaning. And while we focus here on the confidential computing consortium, I think many of the challenges and also trust-related issues extend beyond confidential computing, are a generic problem, where we have, referring also to some of the previous talks, is like the definition of like what hardware are we actually running this on? Who is the operator of that service? Who is doing the verification of the attestation evidence that we are getting from the devices themselves or from the platforms? Osama was just asking that question in the earlier talk, which I think was quite spot on. So we have a couple of different pieces here, and also where does the information come from to make the ultimate assessment? Which I think is a key architectural and deployment considerations that everyone who wants to deploy the technology on a large scale should actually think about, like, where do we get the reference values to indicate, like, what's it's actually a good outcome of what our platforms are providing? Where are we getting the endorsements about the hardware? Where are we getting the trust anchors? Where are we getting the policies? So there are a number of questions. And I stop here and hand over to Paul.
Yeah, Paul, could you give us the parties from the RATS architecture?
Yes,
as well?
I can give you the parties. Yeah, so one of the things I wanted to say to follow on from what Hannes was saying is that the RATS model is a superb conceptual description, if you like, of all of those entities and how data is conveyed between them. But it can come across as a little theoretical, a little academic. I think it's actually good to dress that up as well in some good tutorial materials that actually, I mean, we've heard this afternoon about some of the open source projects and the production systems have been built out of these concepts. But those also, you know, sometimes quite complicated. So having something that is stripped down, that it, you know, has, if you like, RATS distilled to its bare essentials in terms of all of these components and their roles, to have some tutorials around that is something that, so part of my work with ARM is we're actually doing some work on that, and we hope to be making some materials available quite soon. But I may be put on the spot with it in terms of all of the entities. But if you imagine, say, a confidential computing environment which needs to process some data. We know how confidential computing environments work. They have some kind of isolation that means the data cannot escape while in use. And that's great, but how does the data get there in the first place? You know, the data does not start out life within the trusted environment. It starts its life outside and needs to get in. So really, where the RATS architecture comes from is as soon as you start to do a thought experiment of what are all of the steps needed, well, I'm not going to, if I own the data and it's my private data, I'm not going to release it into that execution environment until I can find out something more about it. That execution environment is then the attester. It is the thing that's going to have to yield evidence to me. What am I? Well, I am the relying party. I am the entity that will release those secrets and that data, provided that I am satisfied by the evidence. How can I be satisfied by the evidence? Well, I need to go and talk to a verifier that is going to verify the evidence. Can the verifier work in a vacuum? Well, no, it can't, because the verifier is given evidence, but what's it going to measure that evidence against? There has to be, somebody needs to have yielded a description of a valid system, a known good system in terms of hardware, firmware, and software, which we call endorsement and reference values. And you can find all of that in the RATS architecture. But I think it's good to do these sort of like mental exercises from first principles to figure out where all of these entities come from and why they matter, both from a technical and a business point of view.
Ian?
Yeah. Well, then to address what is trust, which RATS doesn't, interesting. Okay, after building a few attestation servers for many, many years, I think 15 of them in total, I don't care about RATS. So in English you say, I don't give a rat's about rats.
Yeah, let's not go there.
Yeah, let's not go there. I mean, to go back to the original question, yes, I do care very much about rats because that guided the last version we built. Trust is more about, or to me now, the question that we need answered is who and what. Who is this thing I am interacting with? And that's independent of rats, and that's what rats must therefore support. And then what, and sometimes where, and that's often forgotten. You know, we assume, okay, it goes into a cloud environment, we don't care, as long as we get the attestation token back. But when you get down to much more, or certain kinds of distributed systems, certain kinds of resource constrained systems, there's a where question. And then there's the whole notion of trust itself, and what does trust mean, which we discussed very much over a lot of coffee over lunch. And
too much coffee.
Trustworthy? Am I allowed to bring up that term now?
As long as you don't mind knocking it down, but that's fine. Yeah, go with it.
You're not part of the panel. So.
Oh, I'm moderating it. I can talk over you.
Yeah. And, I mean, okay. Then there's trust, and what does trust mean? And trust doesn't actually mean good. Trust means I just know what, where, or who it is. So that's something that needs to be discussed, and then we need probably better terms for trustworthy and attestable as well. And I'll hand back to Hannes because he's desperate to answer something.
Hand it first.
Yeah, maybe I just want to give it in short, because I have learned Rust from the very beginning of my research. So for me, I think people mostly care three main entities, which is the attester who generates the evidence, and then the verifier who consumes the evidence and generates the attestation result. And the third one is the relying party who can finally consume the attestation result and do some specific application actions. Yes.
Thank you. That was the nice, quick answer I was hoping from all three of the previous people. Thank you, Yuxuan, for giving us that. Hannes, do you want to add anything?
You sneaked around there.
You did.
But to pile on to what Ian said about trust, I think one important lesson I learned over the years was whenever someone used the term trust, they should qualify it with who trusts whom.
To do what, in what circumstances, in what context, which is
that's really important.
Literally why I wrote the book about it, yes.
Yeah. Thank you, it's a very good book. But I also wanted to pile on to what Paul was saying about the confidential computing and that specific use case example. And that's a nice example on how the confidential computing use case differs from other attestation use cases. Namely, in this case, we also want to make sure that we establish sort of the way to securely and confidentially provision data and potentially code as well to that environment, which in some other cases is actually not needed. It's not a necessity.
Absolutely. So although it's not necessarily part of the confidential computing consortium's definition of what a TE and a confidential computing is, the confidentiality of the code you're running can absolutely be important, because code can be sensitive itself, right? That's kind of where you're going with that? Yeah.
There are actually some interesting use cases now coming in from the medical side, where, especially related with sovereignty. We're working, or I'm working on one case now. We've got data from Europe that an American company would want to run their algorithms on. We can't give our data to them, and they can't give their algorithms to us for all sorts of interest. So you've got these both two problems that are now coming up, and we don't have a good solution yet. So if anybody has a solution, come and see me afterwards. But yeah, I just want to emphasize actually what Hannes said about code and data, both requiring confidentiality.
Absolutely. Osama had a question first, then we'll get to you, Drasko, if that's okay. Osama. Can we get back to this? There's a question about endorsements and reference values, which I wanted to get to later on. So can you hold that and we'll get back to it, because they're not going to let me get past without talking about endorsements. But let's just finish this bit first. Drasko, you had a
question regarding that case, USA Europe. Is that a problem of legislation or
so the question is the use case that we're being recorded. So Ian put up about Europe and the US. Is it a technological problem, or is a jurisdictional and a legal problem?
Both, unfortunately. Lawyers got involved, now it's difficult. So there's an IP problem for a start, with maybe some technology from one side not being allowed to be used in the other, or not wanting to make too public at this point. So it's an IP and a business issue from that respect. And then from a GDPR, HIPAA aspect, then there is the whole privacy aspect coming in on where that data can run. And then, of course, further to that, you've got national legislation Finland and Germany are very, very strict on this, where data can, especially personal data, medical data, can actually flow as well. So that comes down to sovereignty. So in that respect, confidential computing becomes a method of solving a very intricate legal sovereign problem.
That's exactly what I'm asking. I'm convinced that we can technologically solve this. You know,
So
will this be a good enough evidence for the law, whatever?
So
I think
when will it, how can we make it
can
acceptable?
repeat the question.
Okay, so very, very briefly, is confidential computing a good solution, or can it provide a good solution to the legal the legal sovereign problems? Yes, or it has to be. I mean, the only other solution we have is fully homomorphic encryption, which isn't going to work.
How many years have you got?
Yeah, that's just to add 2 integers together as well. It can do. Now, if you look at legislation like GDPR, which is very risk-based, the way then confidential computing is, I guess, focused is this is a very risk-free technology in the sense that, you know, we can use it safely.
So let's move on. So yeah,
Do you mind if I
go for it?
Very briefly? I think I wouldn't go as quickly as Ian saying, yes, it provides the solution, because in some sense, whenever it comes to that regulation, it's often a case that only later we see some of those data protection authorities, which are enforcement bodies enforcing the regulation, will get together, and they will, based on different cases, they will then come up with some recommendations, which they have done in the past numerous times in Europe. And so I would lean forward to say they will be positive and favorable to the technology. But I'm not aware of such a document yet that they would say this is actually the best kind.
Sure, and if anyone's interested in engaging in these conversations, the Confidential Computing Consortium has a special SIG on governance, risk and compliance who work with regulators and people like that. We've got a queue next, sorry.
It was just one aspect, right? I mean, the data is one, for me, the keys. You were just about to say keys, right? Because also in the remote attestation, at the end of the day, you want to have, for instance, somebody releasing the key so you can access your data. And we had that discussion before with the Google Cloud and confidential. I personally think that a lot of times it's missing, that one of the key aspects is to have encryption and keys, and your service running elsewhere, having a key management system operated by your cloud,
so
predicting your idea of
let's not get into key management systems. We're trying to concentrate on attestation, but who
answer that question nevertheless anyway. So the question was like the comment was that the confidentiality of or the keys used for the confidentiality protection of the data and code and whatever else you have is important, which I think we all agree. And it's a unique aspect of confidential computing. It's not in the RATS architecture because RATS didn't try to solve the confidential computing mission. It's just one building block. There has been another working group in the IETF focusing more on the DE provisioning aspects, which covered some of those aspects. But I believe there is more room for collaboration in the community to actually come up with something standardized, which I think is also something that is important to many of us here, is the collaboration between different stakeholders, different projects, to actually work on solutions together, so we don't replicate all the stuff again over and over again, as we have seen actually with the attestation work. There's lots of repetition, there's lots of mistakes being made and not learned in other cases, so I think there's still room for improvement there.
And we have a forum to do that, which is a Confidential Computing Consortium. We have technical groups to do those conversations. So let's do that. Let's try and just move on quickly from this, because we've got a whole bunch of other things. But Ian?
Extremely briefly then, what you're touching on is integration. And that, I mean, now you've said the system word, key management system. One thing we don't have enough experience of yet is how to integrate these in the large.
So I'm going to move into something different. Osama, okay, quickly. Sorry, I forgot you on the queue. Go for it, please. I'm sorry.
Totally disagree with what Ian said. So I
So the comment is about fully homomorphic encryption and confidential computing and how they interact. And I think I would generally say, from the point of the CCC at least, these are complementary technologies, and we'll find ways to use them together. Just leave it like that. Fine. So there was something that we talked about a little earlier. Well, the question was asked before about endorsements. What is an endorsement, and why do we care? Surely we know we have these different parties. We've defined what the parties. Well, I say we. Yuxuan helpfully define what these parties are. Why do we need anything more than that?
Okay, so yeah, so a few things on endorsement that I could cover. So Usama asked a great question, which is what's the difference between an endorsement and a reference value? So RATS does make this distinction between the two things, and I think that you could take the argument that a reference value is a case of an endorsement, right? A special case of an endorsement. An endorsement is a statement of something that is good from somebody who is authorized to give that statement of something that is good. That's what I would say an endorsement is. A reference value, as an example, could be something like if I've built a blob of firmware that is running on my device or on my system, that firmware compiles to a binary, that binary has a hash, and I can make a publication that says, if this binary was built and it gives you this hash as a result, it's good. If you get any other hash from it, then it could have been tampered with in some way. That is what you might call a reference value, but it also meets the qualification of an endorsement via the definition.
So how I think of an endorsement, and tell me if I'm wrong, let Hannes tell me if I'm wrong, is you need to find a root of trust somewhere, but in order to get to there, you need an authority. Which can say, yes, this is an appropriate root of trust. And the endorsement is the thing that takes you from the authority to that root of trust. Is that a good way of looking at it?
I wouldn't use the word of trust in that context, because that is another can of worms. What is root of trust for one person is different for another one. I can give you then my definition of root of trust in a second, but I a little bit disagree with what Paul said about his definition of endorsements, because I see it, reference values, I think we're on the same page. We have software in some form or the other, and we produce a hash. We want to identify, is this the software we expect the device to be running or the platform to be running on? But then when it comes to description, for example, for hardware, or some other components where you don't really measure something, you actually need to know, like, is this chip XYZ, is that something that is really what it's supposed to be? Like, this is information that comes from outside. You don't really know where it comes from. That's, for me, is an endorsement.
Yuxuan, you've had some things I think you've wanted to say, so please.
Actually, I'm thinking of a question because
That's fine, go for it.
So I don't know if I already have the reference value, do I need endorsement, or like is endorsements very crucial for the remote attestation procedure? Like, is it must?
I would say yes, because the information, for example, I could be running firmware on QEMU versus on, let's say, some latest ARM Cortex-M processor with trust zone. I definitely want to know the difference between those two. And the endorsement would give me information about the underlying, for example, hardware that only ARM knows what it actually built, what the chip manufacturer, let's say Nordic Semiconductor, knows that this specific chip is still fine by today's standards versus something else that is like 5 years old. But it makes a huge difference.
So in the cloud world, and I'm going to move away from the cloud world in a minute, but in the cloud world, what are the minimum set of endorsements do you think we need in order to do this thing? Again, thinking about those parties we had, we need an endorsement for each of those parties. How does it work? Can anyone give me a clue?
No.
Excellent, fine. So we can't go anywhere because we can't get endorsements that we can agree on, or?
Pretty much, I'd say.
Okay.
Okay. We're now going into an area called such as transparency.
Absolutely, yeah.
And I mean, we hit this many years ago when we started on this work. For example, on TPM or UEFI, where does PCR 0 come from?
Yeah.
And it's the bit before that. Sometimes
Bottom turtle.
You know, that's the Big Bang, if you like. So you can't go before that, and it's just all taken on faith. Maybe I'm a bit pessimistic there, but
okay. So, but let's say we've got this chip, and it's going to produce an attestation report at some point. So, presumably, we need an endorsement of that chip, right? And that's going to come probably from the producer of that chip. I mean, the ARM ecosystem is a bit different. Maybe it would be Intel or AMD in that case, but in the ARM case, maybe it would be Fujitsu or Mitsubishi or someone like that. Okay, so we've got that. Do we need an endorsement of the verifying party as well? Do we think? Have to? Might need to? It's gone very quiet. I don't know. I didn't mean to discomfort you so badly.
Yeah, I mean, I think part of the reason we're going quiet is that this is one of those areas where there isn't a single answer to that question, right? I think there is inevitably going to be a minimum bar that satisfies some bodies that want to deploy this technology, and that's not going to be the same minimum bar that another body.
Okay, so what I would like to say is I think we need to discuss this, and maybe not here. We don't have time for that. But this is some work we clearly need to be doing. So, but I want to move out of the cloud. Hannes, want to say something first?
Yeah, I still want to go back to your root of trust question, because it very much relates to this. You were saying we need to have the endorsement of the chip, and you actually want to have the endorsement of the root of trust, the chip, the hardware, and combined with in most cases, there's the first stage bootloader, which is and also like the whole system on chip, and there's a lot of like software, low-level hardware and low-level software pieces that you need to rely on. And the question is also, and that relates to the trust point that Ian made, is if I'm a customer, can I actually make a reasonable assessment about any of this?
Absolutely.
How much do I actually want to be able to make an assessment? How much do I care? Or do I just compare random value against another random value, and that's it? Or do I want to really have some say about, or some insight into what is, for example, running in the first stage bootloader?
And the classic answer to this in the enterprise world is you make it as easy as possible, but you allow people to find out more if they need to, but that's not always easy. So what I wanted to do actually was say, we've been talking about the cloud because that's the way we tend to think of much of this stuff. But Yuxuan, this isn't where you're coming from, is it? You're very interested in the sort of IoT edge world, and I'd love to hear how you think about things differently, particularly around attestation. So please tell us a bit about how you think of the world.
Okay, because I have said that I work for the remote attestation for constrained environments. So in this case, there's no that complicated computation environment. So I would like to share some experience, mainly two challenges, I think. So the first challenge is that for like most IoT devices, they don't have that powerful computation and memory. So actually, we should reduce the memory and the computation consumptions. So in this case, we'll try to firstly run the remote attestation over a lightweight protocol. So instead of TLS, I'm trying to use another also standardized protocol in IETF called ad hoc. And also, for the IoT devices, we want the message size can be as smaller as possible. So we also define the structure by using the standardized EAT to have only the necessary attributes. And besides this single IoT device remote attestation, there's another very interesting challenge for the IoT environments, which is swarm attestation. So as you know, actually most of the IoT devices are working coordinately. So like there's a group of devices. So we also need to perform the remote attestation for this swarm of devices, because imagine you have like a group of drones working together, like you want it to move forward, but like if this latest command is to move forward, but some of the devices have the outdated version to move another directions, then this is not working. So that's why we want also achieve the attestation for a swarm of devices. The solution we have right now is like each single device can achieve a lightweight remote attestation, and then they transfer the attestation result to a central point. But actually, this is still a future challenge because right now I'm working on a single remote attestation implementation. So yeah.
Really interesting. I'm also aware there's some work that Ming Sheng's been doing on zero. What's it called? The zero knowledge proofs, which possibly plays into this area because you're talking about lightweight proofs can be helpful. Any of you folks have any views on any of the sort of this area as well?
Just on the last point, zero knowledge proof doesn't imply lightweight in any way.
No. Agreed. Yes. Sorry.
Yeah, it's an interesting challenge because again, some of us here have been working on these lower end IoT devices, also with an eye on the confidential AI that Lenaro and others have been spearheading. And these devices over the years have become more powerful. So I'm really interested to see like where the direction is going in terms of also those computing resources. Are we going to see sort of a closing of gap between higher end systems in these low-end devices because people are piling on new functionality, like AI functionality. You have all these demand for processing power, security capabilities, et cetera, et cetera. So where is that actually going? That's really something that puzzles me, and I'm looking forward to see where we end up ultimately in this.
The fact that ARM has devices coming out, and ARM is bridging the server sort of edge divide. I'm looking forward to seeing where that goes as well. We have several questions. I'll at the back first. Let's take Derek. I think
Right. Yeah. You mentioned entity attestation tokens earlier, and I just wanted to point out that for the constrained devices, that's really important. An X.509 certificate is the default by a lot of people, and those tend to be those don't seem large when you're used to working on a server, but when you're working on a deeply embedded device, they're prohibitively large. And so entity attestation tokens, if we go in that direction, that tends to favor those smaller.
Yeah, so the point being that EAT entity attestation tokens are much smaller, typically than X509 certificates, which are actually rather bulky, particularly when you're moving them around on the network all the time, right? Thank you. Drasko, is it?
I was just asking about what kind of hardware is doing the measurement at the actual producing the proof there. Is it the CPU, or when you're talking about those embedded devices, how the actual measurement is done?
Yeah, the question is, where's the measurement of, do you mean the attestation measurement or the verification piece?
The attestation measurement.
The measurement, where's that taking place? Yuxuan?
So actually, as embedded devices, there are not that many use cases. So typically, the remote attestation is doing for verifying the hardware and software configurations in the embedded devices. So right now, what I'm working is use case for onboarding check. So here we will have the measurements in the device memory. So we kind of read into the memory and then get a hash value as the evidence. So this is because we found this is the easiest and the way to like have the smaller message size. And also we are now applying the trust zone in embedded devices, but it's done by our engineers in our team. Because we don't have any cloud providers, so actually what we are doing can only be done in the device itself, which is the memory.
But this is software measurement then, not hardware.
Well, I will try to provide my sort of like my story based on work, some of the work some of us have been doing in devices that offer some trusted execution environment, like the more recent Cortex-M microcontroller, let's say M33. There you have the attestation service implemented in the DE side in the secure world. And also that acts as an attestation service But of course, there's a multiple stage process. So during the boot process, already the bootloader collects some initial measurement, passes it up to that attestation service, and the attestation service is ultimately responsible for passing that forward. So it's kind of a low-level service. But of course, as it was said already, it depends a little bit on what your environment is, and some of the older microcontrollers just don't have that capability, so that there are not that many choices left in those cases. But that's a very powerful capability, and ARM has been working on the trusted firmware project and has been providing reference implementations for this. So there is some stuff to work on.
Ian?
We did some work years ago on railway systems. I mean, it started off as what happens if we stick a TPM in everything, which was a stupid idea in the first place. But you know, for example, Eurobalyses, these devices sit between the tracks that give information to the trains as they run over. You might only have 1,000 bytes available to you. You know, so it's a cyclic where you just keep on sending 1,000 bytes of data to the train. You've got about 200-300 milliseconds to process everything and so on. You've got absolutely no budget in there. Plus the device itself might be little more than an Atmel microcontroller at heart. So we did some experimenting where we, for example, attached a TPM to an Atmel microcontroller or an Arduino, etc., and had a look what you can do there. But then you're up against power consumption, you're up against timing constraints, and then you just might not have enough time to send all that data. PCG now has Mars, which may provide a solution, but I haven't seen any decent implementations yet.
Big Planet, red.
Yeah, really, really small resource constrained TPM, apparently. Yeah.
So it sounds like we all want to have lots of attestation. Is it easy to build one? Can we do one now? Attestation verification service?
Yes, I've got 15 of them on GitHub.
Okay, fine. And they work at scale and everyone's happy and they've been fully adopted?
I've got the widest deployed attestation server on the planet, so I've attested like 30 machines at once, so yes.
So why do we not have lots of commercial confidential computing attestation services, verification services?
Integration. I don't know what I'm attesting. I don't know how to attest most of these things. And if you go talk to the managers who sign off on these things, you can't convince them of this. But that's a political question. I don't think we've actually tried to build this at scale, or even just gone out and just done it for fun to see what happens.
Anyone else? Hannes has a view?
Yeah, but in all fairness, of course, confidential computing is a new kid on the block, so it always takes a little bit of time to roll out the technology, work on the different pieces, and it always takes longer than we think. Like as an engineer, we always totally off in the estimate on how long it takes. But we have a couple of successful technologies that rely on attestation, and I think we will see that the same happening in confidential computing as well. I think we are at a stage where we need to seriously think, or companies are thinking about how to deploy this, and then the work that Paul is doing ties into that with his endorsement.
So again, yeah, please finish that, Paul.
Yeah, sure. I mean, I guess so. Going back to the question about why are we not already in that happy world where this is all deployed at scale? I mean, I think we are to some extent. We have a perfect storm of technical difficulty combined, technical complexity. Yeah. Combined with a lot of business complexity and regulatory complexity and legal complexity, and all of these things combining together, and ultimately there is a need to solve all of that, and the question then is, well, what are the incremental steps we can take from where we are now to where we want to get to? One of the things that I'm working on at the moment is looking at some parts of the RATS architecture, and in particular, so for instance, where we can identify bits within RATS where it's possible to draw a circle around part of it and concentrate on this one part and say, if we were to build a standard of some kind
for just that bit,
for just that part of it, then we've solved an interesting technical problem, which gives us a building block. And preferably, so I'm concentrating on the world of endorsements and how to convey endorsements to a verifying party. There are things in the standards world that are already relevant to that. Standards like CORIM, for example, the concise reference integrity manifest.
Well done.
So there is that, but in terms of like APIs and interaction patterns and trust patterns, we don't have standards yet for all of those things. And I think it's important to try to define them, not only to define them because then you just have documents, but I think it's also important to prove them out and to prototyping. And there is a growing wealth of projects now in the CCC. Verizon being one of them that I'm really interested in. I think Verizon, it's a great project in lots of ways. One of the things it very definitely is a learning and experimental platform for building new capabilities in attestation, both in terms of verification and also, I think, in terms of endorsement. So I think taking the RATS architecture as like the conceptual framework of a system, proving it out with prototypes and then contributing into these CCC projects so that the building blocks are there, because when you have building blocks, you don't need to have solved every commercial problem. You are not necessarily making an opinionated statement of who is going to run this service. Is this going to be a single central global service? Is it going to be per manufacturer? Or is it going to be offered by regulatory bodies or by other entities? You don't have to make those determinations now. They will be made in time.
Ian.
You just described agile methods. Yeah. I can't emphasize enough actually just going out and just building it and integrating and seeing what happens. Yeah.
So we're getting towards the end, and I'm going to give each of you about 30 seconds, okay, to say something you're excited about or sad about or worried about. We're going to start. No, we're going to start with Ian, and then we're going to move on down. I would say that the CCC is currently doing some work on business models for attestation verification services, because we know that there's a problem that we need to discuss how this would work and those sorts of things. So please get involved in that. If you're interested, get in touch with me. Right, Ian, off you go.
What excites me?
To do with attestation, please. Yeah, okay, yeah.
You have no idea.
Now that I want to know.
Actually, what really excites me about this is the prototyping, which I've done for many, many years, but also what's actually behind this in terms of data models, ontologies, the action models that we have on top, and how all these come together. I can talk for hours on that, so I'm going to give the microphone straight over to Paul.
Thank you, Paul.
Thank you. Yeah. So actually, I probably should have saved some of what I said earlier as my because that is kind of what excites me. But I'm excited by a lot of what I've heard this afternoon. I think actually the growth of projects, these building blocks that are emerging as CCC projects and in open source. The future of confidential computing is absolutely in open source, right? It needs to be, because part of confidential computing is nobody wants to be in the implicit trust loop anymore.
You need trust and transparency.
Yeah, exactly. It's all about transparency. So I'm really excited by what's possible with open source and where we can define these new interfaces and where we can prototype them. And but yes, there's lots of work to do. So it's all about finding those next incremental steps.
Hannes.
Yeah, I'm excited about the progress we've made on standardizing the building blocks. There has been lots of groups working together, recognizing the need for having these building blocks, and then to actually make this happen, what you, Paul, just said, putting them together. And for example, in organizations like the CCC, which take the different pieces, put them together into different systems. And that makes me really happy.
Good, thank you. And Yuxuan?
Actually, I don't have that much to say, but talking about transparency, because I'm also working on IETF draft for defining how to do remote attestation over a lightweight protocol. So also, meanwhile, I'm also doing the implementations. And of course, what I'm doing is also open source. And last one, yeah, there's still a lot to learn for.
Perfect. Well, I'd like to say on behalf of the CCC, we'd love to have you present on the IoT world and, in fact, on the lightweight stuff. And we always welcome people who have interesting things to talk to any of our groups about, particularly the TAC. People, every 2 weeks we have at least half an hour set aside for an external person to come in and talk about what they're doing, and we're very happy to hear from all of you, or any of you, or a number of you have done this already. I'm looking at Thomas. Andras, actually quite a lot of you, so that's fantastic. And Osama, yes. So thank you very much to all of the panel. We are ending pretty much on time. Thanks for all of your input.